All right, ladies and gentlemen, we are looking at 6.5, triangles are similar. Two new things to go on your vocabulary sheets. Side, side, side. If the corresponding sides of two angles are proportional, then the triangles are similar. And side, angle, side. If an angle of one triangle is congruent to an angle of a second triangle, then the lengths of the sides included. Did I skip something? If two sides of a triangle are proportional, the triangles are similar. Side, angle, side. If an angle of one triangle is congruent to an angle of a second triangle, then the sides of the triangles, including in the one more time. If an angle of one triangle is congruent to an angle of a second triangle, we're there so far, right? And the lengths of the side included, these angles are proportional. Including these angles are proportional, then the triangles are similar. All right. So you guys know what side, side, side means. It's like, if the sides are all proportional to all three. Side, angle, side, if the angle in between the two sides that are proportional are the same, are the congruent, then it's similar. Okay. Let's go through some of these. All right. Two out of these three triangles, are similar. We want to find which ones are similar and then tell us what the scale factor is. Do you remember what scale factor is? That was a while ago. So we solve the proportion. We don't solve the proportion, but we set up a ratio, like a fraction. And the ratios are reduced to the lowest one. Okay. Which ones do you want to do? We could do the blue one, the red one, the green one. Which ones do you think are proportional to each other?
Blue and green.
You think blue and green. Okay, let's set it up. All right. You think A and B is the corresponding side to what for the green one? ED. So that would be 2 over 8. Okay, we want to see if it's set up to what? What would the corresponding side be for 20, AC? DF, so 14. And we want to see if that is corresponding to the last ones would be, oh, did I mess this up? I should have done, I'm doing green over blue, green over blue. Okay, 2 over 8 reduces to 1/4, right? 14 and 20, 2 goes into both of those. 2 goes into 14 7 times and 20 10 times. Are those proportional to each other? Are those the same fraction? No. Okay, so we know blue and green are out. All right, so we know one of them's got to be proportional to the red one. Which one do you think, the blue or the green? I think the red one's to the blue, okay? So it would go, we're going to put blue over red for all of these, just so we remember. Okay, let's look at AB is 8. What is the corresponding side for that one? GH 6.4. Okay, AC is 20. What's the corresponding side for that? 16. And BC is 17, so the leftover corresponding side is? 13.6. Okay. So instead of reducing all these, I'm just going to divide and see if they're all the same. 8 divided by 6.4 is 1.25. 20 divided by 16 is, oops. You have to put it in your calculator correctly or you won't get the right answer. 1.25. And 17 divided by 13.6 is 1.25. Okay, those all equal each other. So we know blue is similar to red. But now I have to figure out what the scale factor is. Which one of these would be easiest to figure out the scale factor? Which one doesn't have a fraction? 20 over 16. So let's reduce 20 over 16. What's the biggest number that goes into both of those? 4. 4 goes into 20 how many times? 4 goes into 16 how many times? 4. So 5/4 is my scale factor. Should we do another one, or are you guys good? Okay, let's do one more. Just one. B or C? B. Okay. All right. Well, this helps because you're all right triangles. You guys got to sit up. I know you're tired. I'm tired too. It's the first day back from break. Okay. All right. Which ones do you think are together? Red, blue, green. Which ones do you think are similar? Think red and blue. Okay. So ZY goes with which one for this one? SR. SR. Is the same as XWY, excuse me, which is 4, goes with which one? Which is 5. Are those the same thing? No. Okay. So that won't work. So we know it's not blue and red. What ones do you want to try? Do you want to try green and blue? Sure. Okay. So I'm going to put green over blue. So I've got 7.5. What's the blue corresponding side? 4. And the green is 10. The blue corresponding side is 5. Okay. So we're going to go 7.5 divided by 4 gives me 1.875, and 10 divided by 5 gives me 2. So does that work? No. Okay, so we've tried red and blue. We've tried green and blue, so now we've got to try green and red. So I'm going to do red over green.
Can we just say it's similar?
By process of elimination? No. Because we could if we didn't have to do a scale factor. Okay. So we've got 3 over 7.5 equals 4 over 10. So 3 divided by 7.5 gives me 0.4. 4 divided by 10 gives me 0.4. Which one does not have a, so we know they're proportional. Proportional. Okay. 4 over 10 would be the easiest one to reduce. What would that reduce to? 2/5. So that is my scale factor. Okay. All right, let's turn it over. Okay, let's look at A for example 2. We want to use side, 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 or side, angle, side. What do you think this one would be, guys? Side, 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 or side, angle, side?
Which one?
A. Side, and we've got an angle, side, side, angle, side. Okay, so let's make sure they're proportional to each other before we move on. We've got, what goes with 12.8? 16. Okay, so this is a harder one. Do I know what T to C is?
Yes.
What is it? It is 16. How did you know, Dana, that it was 16?
Because you know that A to T is 4, so you know 20 minus 4 is 16.
Right. And the big one is 20. Now we can just divide these and figure out if it's the same thing to prove that they're proportional. So we get 0.8, and 16 divided by 20 is also 0.8. And if we wanted to do a scale factor, we would get 4/5 because we would reduce 16. Feel good about these? Do we want to move on?
That is?
Yeah, that's it. Do we want to do B or C?
No.
Okay. I am going to skip the proof for now. All right, guys. All right. Let's look at finding. I'm going to wait. You're wasting your own time. We're looking at example 2 for 6.5b, number A. And we know these two triangles are similar. How would we find H?
The proportion.
Okay, how would I set up the proportion though?
6.5 over 90.
6.5 over 91. So we're saying those are corresponding sides.
And then
5 over 8. Corresponding sides over corresponding sides. And then we'll cross multiply. So we get 6.5 H equals 455 divided by 6.5. H equals 70. I want to do one more because this one I think looks a little tricky. It might seem obvious, but there's a trick. I would put H over what? Okay. And then I'm going to put 7 over what? No. 28 plus. Because I want the whole thing, right? And this part right here is 28.
Or say you do
So.
28 plus 7.
Yeah. So it's 35H equals 175. Divide that by 35 and we get H equals 5. Okay, let's do this story problem and we will be done. Okay, so you have a really nice picture on yours and I don't on mine, so sorry. Okay. To determine the height of a pine tree, you place, so I'm going to draw a little picture because I think it makes sense. So here are you.
Just the figure.
Okay. You are 6 feet tall, and you are 2 feet away from a mirror. The tree is 24 feet away from the mirror, and you want to figure out how tall it is. How are we going to do that? We want to figure out how tall the tree is. Okay? So we've got our height over what? The distance between the mirror to the tree or the height of the tree?
The mirror. No.
My height versus the height of the tree, which is x. So the distance from me to the mirror is, the distance from the mirror to the tree is 24?
Well, I don't know if you add.
No, because I want to know the distance from the mirror to the tree. 6 times 24 gives us 144 equals 2x. X equals 72. So the tree is 72 feet. And you can literally do this. You could go outside right now and figure out, let's say you wanted to know the height of the flagpole outside. I have done this before. You place a mirror on the ground. You measure the distance between yourself and the mirror to the flagpole. And you have to walk back the distance between you and the mirror. It has to be so you can see the top of the tree in the mirror. Okay. You measure the distance between you and the mirror. Measure your own height. Measure the distance between the mirror and the tree, and the mirror and the flagpole. And then you can set up a proportion. So you can find the height of anything you want to. You can find the height of the, Empire State Building. Okay. You just have to have enough room in order to see the top of the Empire State Building in the mirror and to be able to find your distance. So you don't have to take a measuring tape and measure from the bottom of the mirror to the top of the Empire State Building.
That'd be hard for Empire.
Okay. All right, ladies and gentlemen, you need to get out your writing.